Good evening, everyone. I'm Henry Paper. Welcome to Indiecade East. I'm the 2016. I'm the co-chair of the conferences along with Jenny Robinson Paper. Really happy that you could join us for what's been a fantastic day of programming so far, and we'll continue on with Mike's program talk. I just want to talk about a couple of things really quickly. Tonight at 6:30 we're having a kickoff sort of party. It's in the DLS, and it will feature. Oh, it's. Oh, what? Spoilers! Don't kill me! Nothing.
Good talk.
And what could possibly go wrong? Okay. Sorry about that. We're working through today pretty good. Anyway, 6:30 tonight. We've got. I'm just going to do this again. I'll just do this the old-fashioned way.
Encore.
All right. Thank you. 6:30 today. We've got a party to kick off things. It's going to feature Cadence Weapon, a DJ who's in the game Loud on Planet X. You'll also be able to play that game amongst other cool games. There'll be beer and other refreshments. Tomorrow morning, we've got a great talk at 11:30 with Sony, with Richard Marks, who's going to tell us about what works and doesn't work in VR. And I'm going to listen to this guy because he's going to ship, the PSVR into the homes of millions of PlayStation 4 owners. So I can only assume he doesn't want them all puking in unison, because I think that might do something to the tides or something. I'm not really sure, but I think that's a real problem. And also, who's got games that they want to submit to Indiecade for LA in October? Yeah, got some games? That's good, because now's the time to do such a thing. Well, not now, but when you get back to your hotel, you can do a quick build and submit it, right? Okay, so we're going to be talking today with Mike Lazer Walker, who has the coolest name ever, and he's going to be talking about making weird things with deep machine learning. You'll also be able to check out Hello Operator, which is in the Strange Arcade. Is that true?
Yes.
That's right. You also had to show that at GDC, am I correct?
Yes.
Yes. See, I'm paying attention. So, without any further ado, let's get up here.
Hey everybody, this is Making Weird Things with Deep Machine Learning. This is going to be a bit of an oddball talk. I was inspired by this track being called Weird Science, and consciously wanted to talk about something that I think is really awesome, but is totally outside of what I do in my day-to-day life. So as Henry said, I can maybe go forward in my slides. There we go. My name is Mike. I am at Lazer Walker on the internet. Yes, that's my real last name. Yes, it's my birth last name. I work with the MIT Media Lab and the Playful Systems research group. Most of what I do is looking at location-based, site-specific storytelling. Sort of one part audio augmented reality, one part immersive theater like Sleep No More, one part interactive fiction. That's mostly a list of buzzwords to say, come talk to me afterwards if that sounds cool. Two other shameless promotions before I get started. I have not one but two games here at Indiecade. Tomorrow night at Night Games, I'm showing a game called Chirp Club. This is a massive local multiplayer game that's all about how do you take what's really great about high-level competitive play and make it super accessible to people who don't play games or don't want to put in 10,000 hours. It's really accessible, it's fun, it's kind of like Just check it out. Also, as mentioned, Hello Operator is upstairs in the Strange Arcade. This is an actual telephone switchboard from 1927. It's absolutely stunning, and I'm not going to show it that much more because it's 150 pounds of 90-year-old hardware. So you should probably check that out while you can. So yeah, deep machine learning. This is sort of a field, particularly something called recurrent neural networks, which we'll get into. This is something that's exploded the last couple of years in computer science, largely because of major improvements to GPU tech. Maybe the last year it's also gotten really huge in the art world, and people are starting to make really cool, interesting things with it. It's also become a bit of a buzzword that is going to solve all of your problems. Spoiler alert, that's not true. But what's cool is there are a lot about these things that are really, really powerful, but also really accessible. If you know enough programming and technical skills to make a Twitter bot, you can probably do something really cool with neural networks. Yet most people don't, because they think it involves a lot of math and a lot of really scary things. And so the two things I really want to do today is I want to demystify that, and I want to get into what is it about these that are cool, what's interesting about them, what can we do with them. So based on that, we're going to start with talking about neural networks and dive a little bit into the theory. Very high level, I don't want to get into math, but I'll tell you a little bit about what these things are and how they work. Then we'll look at sort of if procedural generation and generative art using neural networks is a sort of design medium or artistic medium, what are its affordances, what are its constraints, why are these things beautiful, what can you do with them, and then very briefly we'll touch on if you actually want to do this, what can you do, what are the tech tools you have at your disposal. So before we start, I work at MIT. I'm a pretty good programmer. I have a piece of paper that says computer science from a liberal arts school. I think of myself far more as an artist than a computer scientist, so take all this what you will. And as I touched on, procedural generation is not a silver bullet. You are not going to be able to use any of this to just instantly generate levels for your game or write a novel without having to do any work or anything like that. If you've done any work in procedural content generation or generative art before, you know this is true. At the Media Lab, we just started up an AI initiative where for us, AI doesn't mean artificial intelligence, it means augmenting intelligence. The idea being that what isn't great about computers is that they can do what humans do. It's that when humans and machines collaborate, we can do something far better than either of us could. In games, Splunky being perhaps the best example of this. If you read Derek Hughes' book, he's very clear about the fact that Splunky doesn't work because it has a great algorithm. It works because he had a very careful hand in figuring out what parts of the level should be hand-generated and which parts should be computer-generated. Sort of similarly, you may have seen Tay, Microsoft's chatbot that was released a month ago now, maybe. This ran for 2 years in China and it was great. And within 24 hours, it became a racist and sexist. But just to understate, like, we're really not solving technical problems, we're solving people problems. And finally, similarly, neural networks are not a silver bullet. If you are interested in making weird, procedurally generated things, great. There's a good chance a lot of them I'm going to talk about today is completely irrelevant to you. There are things that neural networks and machine learning are great at, which we'll go into, but there's also a lot of great traditional procedural generation techniques. If this is all new to you, Kate Compton has an absolutely wonderful blog post where she goes through basically, here's the state of things, here's what you might use. Harry Giles has another great one sort of focused specifically on poetics. If you want those links, there'll also be a link to these slides at the end, so you can grab all these links. So what is machine learning? In broad strokes, it's all about taking some data, getting an algorithm on your computer that can take that data, generate some predictions based on that data, and then ideally learn and improve based on new data. This is a weird example I stole from Wikipedia, where you've got an animal and you know its domestication and its size, and you want to figure out, is it a cat or a dog? Because that's a problem we all face in our day-to-day lives. But crucially, you can see that as it gets more data, it starts to, that dividing line between cat and dog gets finer grained. And if this looks like linear regression or statistical analysis, you're right. Machine learning and stats are sort of two sides to the same coin, or two different approaches to the same problem. Specifically, though, we're looking at neural networks, which are a type of machine learning that is based on the brain and looking at how do neurons work, how do they interact with each other, can we use computers to model that in a way that is useful. So you have a bunch of neurons, where a neuron is really just four things. It has inputs, which is the fixed set of things, weights that are given to those inputs. This is the machine learned part that these weights are going to update over time. There's an activation function, which you, as the person creating the neural network, are going to provide. There are a couple of standard ones that you're going to use most of the time just because they have properties you want. And then finally, based on that, you have some outputs. If you're a mathematician or a programmer, you can think of this as a pure function. If you have some inputs, and those inputs have the same weights, and that have the same activation function, you're always going to get the same output. And so all you really do for a neural network is you layer these. So a layer is a whole bunch of neurons that all share all the same inputs. And then all their outputs go somewhere else, presumably another layer of neurons. And so you can start to see you have these sort of layers that are doing computation, where really all they're doing is taking those weights and those activation functions and passing along data. To make this a little more concrete, say you have a couple million photos. And because I know the currency of the internet is kittens, I want to know which of these photos have kittens in them. This is a classic machine learning problem called image classification. And you solve it sort of with this sort of tool. You use a specific type of network called a convolutional neural network that is different in subtle ways that we're not going to get into because the complexity is not really worth it. But essentially, it looks something like we just saw. But the catch is if you sit down and think, okay, we have these neurons, there's some numbers, there's some math. How do we actually go from 2D gridded pixels to Boolean or probability that a photo contains a cat? You're right, there's not a lot to work with there. But the secret is that thing called the hidden layer. The secret is really an abstraction. It's not one layer, it's a whole bunch of layers. Where each of those does a nice small isolated unit of work. Or say, your input is your two-dimensional grid of pixels. The first layer might be looking for, like the neurons will activate if there's a sharp edge or a colored blob, or these sort of very simple things that we can detect when you're looking at pixels. The layers after that take those as its input are going to start doing things like, is there a nose, is there an ear? Until by the time you get to the very end, you'll have these neurons that can fire pretty clearly on, is there a cat in this photo? To see what this looks like, there's some folks in 2013 who did some cool work visualizing these. You can see on the left what was being activated versus the actual image being passed in. So you can see in layer 2, sort of pretty early on in the network, I think this whole one at 7, you're getting these sort of beautiful pattern-like figures, whereas even one layer later, you get things like that one in the middle on the left, it's clearly activating on a car wheel or asphalt or something like that. And again, the computer doesn't actually know what these are. It wasn't programmed. It just sort of figures out, okay, here's a shape that interests me. I'm going to activate based on that, and that will pass that data along the chain. That's sort of at a high level how that works. Again, I wouldn't be able to expect you to sit down and program this sort of thing based off that. But at least you can understand now, this is how you might build up such a system to do something like this. The other important thing to talk about is there's another concept called recurrent neural networks. These became really popular pretty recently, particularly this guy named Andrej Karpathy. That link in the bottom is a blog post he wrote that's really great and talks about why these are beautiful. But they do this really cool is instead of the input to a neuron being whatever input it's being set, it's that plus the history of every single neuron it's gotten before. And it turns out that that concept of history or state is incredibly useful when it comes to generating text, as we'll see in just a few minutes. There's a lot that we're skipping over. That's okay. Again, this is a very deep rabbit hole you can go down if you want to start learning about this. So if this was longer than a 30-minute talk, I would want to step back and say, okay, when we talk about procedural generation and generative art and computers making things, what do we care about? What is beautiful? What is emergence and spontaneity? And what do we want? Oh, we got time for that? So how many of you know what a Markov chain is? Okay, good number of you. So it's a sort of relatively simple form of statistical modeling used in many sciences and really commonly in things like Twitter bots. This is given a corpus of some data, let's say in our case often text. You can generate sort of new data that looks like that based off of probability weightings. So given the text of Shakespeare, and then given a word, or a set of 2 or 3 words, what is the most likely word that would come next based on historical data? So this is a Markov chain that is generated on the rules of Magic the Gathering. And some of these are kind of fun, but you can already start to see the cracks. Like particularly if you look at that one on the left, you can see like that losing that sense of history. That the idea of something coming from a player's something probably occurs a lot in the Magic rules, as does the idea of a player's life total. But the concept of Magic cards coming from a player's life total obviously makes no sense. And, this isn't bad, like it's kind of funny, they're coherent English sentences, but it doesn't really capture the essence of the data set that we're trying to make new works off of. And to be fair, this is a really bad example of Markov chains. There are a lot better ones. And a lot of you have probably used these sort of make your own or ebook style Twitter bots to use your own Twitter accounts. But I mention this because this is a bot called Rosewater, which is an absolutely wonderful Twitter account that has been given every single Magic card and uses RNN to generate new Magic cards. And what's great about this is not only to just really quickly start to figure out both sort of the explicit rules of a magic card. Every card has a casting cost, it has a type, if it's a creature it has a power and toughness, and it figures these out in a relatively unstructured way. You can just give it the example data in a specified format, and the output generally tends to look like that. You can use RNNs to generate structured XML while all the tags actually close. But more importantly, it starts to learn the implicit rules of magic. And you'll see it knows that green creatures tend to be large, and red spells often deal damage, and white creatures might be angels or might have flying. And it does this without any input from us, which is really cool. So if you look at a couple really good Rosewater cards, the one on the left is a bit of a fail-state. It doesn't make too much sense. But it is a relatively coherent failure. It is a land that does not have a casting cost. Lands often do something when they enter the battleground. You can see where it's coming from. The second one is amazing, because it has something resembling really coherent theming. It is a cat that makes bird creatures move away really quickly. Like sure, with any sort of procedural generation, sometimes you will just knock it out of the park, and it's possible this is just rolling the dice. It's also very likely that there are cards in Magic that have sort of interactions between cats and birds. I don't know, but it's that last one that really gets me. But like this, maybe it's not playable in the current meta. I'm not really a Magic player. But this looks like a Sliver card. It's got Sliver in the name, and its creature type is Sliver, and it's got a rough cost and power and toughness like you'd expect for a Sliver, and its text is a coherent English sentence that plays exactly like a Sliver card with valid Magic rules. That is really, really cool. This system is figured out just through that same system of building up the history of what words come after other words, but with full knowledge that it's figured out this is how Slither cards work. And you see this sort of coherence and thought throughout RNN-generated Twitter bots. This is Deep Drumpf, who was trained and again, sure, it's funny, they're coherent, valid English sentences. But more importantly, like, these are expressing really complex, coherent thoughts. And of course, like, the computer has no idea it's making this joke. It's just assembling words. But because of the implicit relationships in the structure of a text that even we as the authors of our text don't realize, it's able to find these implicit relationships and make them clear to us in a way that is surprising and interesting. And crucially, so you look at Pentamatron or Two Headlines, are the two classic Twitter bots. If you don't know them, Pentamatron takes random tweets from anywhere in the fire hose that happen to be iambic pentameter rhyming couplets and retweets them together. And Two Headlines takes random headlines from Google News and does sort of find and replace to make it sound like they're about other things than they are. These are both great, I love them, they make me laugh. But they generally make me laugh in the same way. Whereas when I look at things made by this sort of recurrent neural network, they tend to surprise me, and I laugh in ways that I don't expect to laugh, which to me is magical. And so this is a brief example. I mentioned this is a guy named Ross Goodman who works he's a student at ICP, doing wonderful work with generative poetry. And I mentioned this both because he did an absolutely amazing Medium post that you should read if you haven't and are interested in this, but also that he is doing work with longer length. And if you read this, like this is recognizable as poetry. It doesn't seem like poetry that a human would write, but it's definitely poetry and definitely feels interesting, and again, more internally coherent in its internal logic than you would expect something from a computer to generate. And the fact that this scales beyond 140 characters, to me, is very promising. And so finally, this is Google Deep Dream, which I suspect many of you are familiar with, but may make a little more sense now that we've talked a bit about how these neural networks actually work. That this actually came out of a very serious research problem Google had, which is when you have this network that's supposed to generate kittens, and it's not actually activating when it finds a kitten, what's going wrong with it? You can't just poke a neuron and say, hey, what are you looking for? Because it's not aware of the facts. When you have the network that's activating when it looks like it sees a car wheel, you don't know if it's actually looking for the car wheel or the asphalt. It doesn't know that. So their insight was, hey, if we take the neuron, take any given neuron in a layer, and we tell it, hey, take that thing you activated on, make the image have more of that. Show us what you activated on. You can start to see what's going on. And so if you do this at the early levels, you get more brushstroke-like patterns. If you do it at the layer that's looking for a dog, it turns out you find dogs in everything. And so this is cool, this is great, but to me there's something much more beautiful that came out of it, which maybe this is obvious to you, maybe it's not, that the natural progression from this is essentially why do these two things have to come from the same source? And so this is neural style. This is an algorithm that the image on the left is a photo of the Golden Gate Bridge, sort of done in the style of Starry Night. The right is when I generated my generic social media headshot, done as a Van Gogh self-portrait. And this is absolutely stunning to me for something that you can generate for in about 10 minutes and about 25 cents of computation time. And again, it shows the beauty and how we're recognizing the patterns of art and being able to apply them computationally. In a way that is both really practical. I want to see games using this art, whether pre-generated now or 10 years from now, and these can be real-time shaders. But it also suggests to me a really interesting and well-trodden path of these really cool things starting out as academic research projects, and then artists saying, oh, this is really cool, we can do something way better with this. And in this case, Neural Style was also an academic research project. But I don't necessarily think that needs to be the case. I think there are enough high-level neural network libraries that more artists can and are starting to be doing more with this. So I want to see more of that. So finally, if all this has piqued your interest at all and you're wondering how do I start doing any of this, as I've been saying, it turns out this is all really accessible. At a high level, if you just want to get your feet wet, there are a lot of online third-party APIs. Some of you may have seen Microsoft's, I'm blanking on what it was called, but they had released a service a week or two ago where you could upload a photo and they would tell you what they thought was inside the photo. That's using this exact same sort of technique we've been talking about. They have a whole bunch of other APIs where you can throw a photo that has a bunch of faces in it and they will tell you what emotions and things are going on in that face. There's a lot of really cool stuff you can do with this, but they're basically giving it away because their goal is to get you into their ecosystem. And you can do some really cool bots with that. But also, a lot of the stuff I've talked about, like Rosewater or Neural Style, you can download these yourself. You don't even have to know how to program if you know how to use a Unix command line. There are very detailed readmes to set these up on your own computer and instantly start generating your own data. And from there, it's not a huge leap to start using something like Torch RNN. That one at the bottom is another RNN sort of pre-trained system you can throw your own corpus of data at and start generating your own text. This is a really easy on-road to start learning about what are, how do you choose how many layers to have in your network? How do you choose an activation function? How do you, all of these things that you will eventually learn. I'm clearly coming at this from the standpoint of someone who learns by making things, so I'm showing you things that say, hey, you can dive in and tinker yourself. There are also obviously lots of other cool online visualizations and MOOCs and that sort of thing to learn, but to me this is what's so accessible. You can download code and have something up and running yourself. That Neural Style image took me maybe an hour start to finish to learn, from cloning the Git repo and following the instructions to having a produced result, never having done anything like that before. And the final point to that is, I don't know how many of you are familiar with AWS or EC2, but this is Amazon basically running the internet, and you can go and very cheaply rent servers in the cloud from them. If you try to do anything like this on your home computer, something like Neural Style, it'll take 10 minutes to generate an image on a very powerful graphics card. If you try to do it on a consumer CPU, it'll take about 12 hours. And even on your own home graphics card, it might take a long time, whereas Amazon will rent you a very, very powerful graphics card with a computer attached for about 50 cents an hour, which starts to get pricey pretty quickly if you want to do larger scale projects, but is really accessible if you want to get your feet wet. And they're also very good at, since their bread and butter are large companies, they love to throw money in the hundreds of dollars at people like us to do cool stuff. So as a concrete example, if you have a .edu email address, you can go and sign up for the GitHub education pack, and they'll just give you $100 of free credit, which gives you a lot of leeway to do cool stuff with. So yeah, that's all I got. Go forth and make cool things.